For section 3.2, we're really going to be looking at slope. We're going to be looking at what it is, how you can find it, and how you can graph it. We're also going to be addressing how to graph from slope-intercept form, or y equals mx plus b. The definition of slope is the steepness or flatness of a line. So what slope does is it determines how steep or how flat a line is going to be. There's 4 different types of slopes that you're going to see. The first is a positive slope. So remember, we read left to right. So if you're reading this graph left to right and it's going up, it's positive. If you're reading left to right and it's going down, it's negative. And then there's also vertical and horizontal slope, which we talked about a little bit in the last section. Now let's talk about how to find slope. You're going to be asked in this unit to find slope from 2 points. Well, if you remember back into your Algebra 1 days, there's a formula for slope. When you've got 2 points, all you have to do is subtract your y's on top and subtract your x's on bottom, and it's that simple. So let's say, for example, I give you the points -6, 9, and the points 3, -5. And I ask you to find the slope between those 2 points. What you're going to want to do is you're going to want to subtract the y's on top and subtract the x's on bottom. So for ordered pairs, you've got an x and a y and an x and a y, and you've got point 1 and point 2. So we've got x1, y1, x2, y2. And if you look at this equation, all you do is plug it in. So for y2, it'd be -5 minus y1 is 9 over, and then do the same for your x's. x2 is 3 minus x1, which is -6. So what that becomes is -14 over 9. So the slope of this line is -14/9, or negative slope. Now let's talk about how to find slope from an equation, which can be a little bit more difficult. And you're actually tested on finding slope from an equation several times in Unit 3. Let's say, for example, I give you this particular equation and I ask you to find the slope. When you're finding slope from an equation, what you want to do is get the y by itself. If you can get the y by itself, the slope is always going to be that number in front of x. So if you can get the y by itself, the number in front of x will always be your slope. So what we're going to do is we're going to take this equation, we're going to manipulate it using the rules we used in Chapter 2. So if I want to get the y by itself, I'm going to move the 3x and the -4. So the first thing I'm going to do is I'm going to minus that 3x over. Remember, I want to get it away from the y. Well, what's 12 minus 3x? Well, 12 minus 3x is 12 minus 3x. You can't put them together. I'm going to pop my -3x to the front, and I'm going to pop my +12 to the back to keep that in descending order. You want that x to come first. The next thing I'm going to do is I'm going to divide by -4. Now remember, when you multiply and divide, everything gets that -4. So this becomes +3/4 x, and this becomes -3. Positive divided by, let me go back here, positive divided by negative is a negative, negative divided by negative is a positive. The slope of this line is that number in front of x. In this case, the slope of the line happens to be a +3/4. Now, let's talk about parallel and perpendicular lines, because we can determine if 2 lines are parallel or perpendicular based on their slope. So if you remember from geometry, parallel lines are 2 lines that are never going to intersect. And what that means is their slopes are going to be exactly the same. And I mean exactly the same. If their slopes are exactly the same, and if we would graph them, those 2 lines would never touch. They would look like parallel lines. Perpendicular lines are 2 lines that form a 90-degree angle. So in other words, when they crisscross, they form that 90-degree angle. Their slopes are negative reciprocals. Now, what is a negative reciprocal? Well, a negative reciprocal means one of the slopes would be something like 2/3. The other slope would be flipped and an opposite sign. So opposite reciprocals mean flipped and changed the sign. So 2/3 and -3/2 would be considered negative reciprocals. If we would graph lines with slopes that were negative reciprocals, they would create 2 perpendicular lines. Now don't forget, lines don't have to be parallel or perpendicular. They can be just 2 normal average lines. And that happens too. And when that happens, they're neither the exact same or negative reciprocals. They're just 2 normal slopes. And that means they're just 2 normal lines. Let's look at an example. Let's say I would give you line 1 has the points 5, 2 and 1, 3 on it. Line 2 happens to be -4x plus y equals 3. So what I need to do is I need to find the slopes of both of these lines, and if I can find the slopes of both of these lines, I can determine whether they're parallel, perpendicular, or neither. So to find the slope, you're going to subtract the y's. So 3 minus 2 would be 1. 1 minus 5 would be negative 4. It looks like the slope of the first line is 1 over negative 4. Let's look at the slope of the second line. To find the slope of an equation, remember we've got to get that y by itself. So in this case, I've got to add that 4x over. The slope then becomes the number in front of x, in this case positive 4. Or, if we made that a fraction, 4 over 1. These two slopes are negative reciprocals. One is 1 negative fourth, one is positive 4 over 1. If they're negative reciprocals, that means they're perpendicular lines. If we would graph these two lines, they would create a perfect 90-degree angle when they intersected. Now, the last thing we need to look at today is actually how to graph slope. So what I'm going to do is I'm going to give you a line that's written in slope-intercept form. And what does it mean to be written in slope-intercept form? To be written in slope-intercept form means the y is by itself. You cannot use this method of graphing unless if the y is completely by itself in the equation. Now, to do that, you're going to have to know how to graph slope, which is why we do it in this section. When you graph from slope-intercept form, you always want to start off by graphing your y-intercept first. Now, your y-intercept is always this number that's by itself. In this case, my y-intercept happens to be at positive 2. So I would go to wherever y equals 2, and that's where I'm going to start this graph. So from here, my pen is going to just kind of hover above this positive 2 in the graph, and I'm going to move my slope. What do you mean move my slope? Well, there's two different ways to do this depending on whether it's positive or negative. This happens to be a positive 1/4. If it's positive, which it is, you can either go up and right. So in this case, I could go up 1, right 4, up 1, right 4, or you can go down and left, just depending on what works for you. So if you watch my pen over here, I'm going to be hovering right above this point. I've got the option to go up 1, right 4, and put a point right there. Remember, we started our original point, up 1, right 4, and I could do that as many times as I want. Heck, I could go all the way through the graph if I wanted to. Or from this original starting point, I could go down 1, left 4, down 1, left 4. And once again, you can do it as many times as you need to. Heck, you could go all the way through the graph if you want. And what that does is that creates a line. That creates your line by using that slope. The one thing I want to keep in mind, you guys have to start at that y-intercept. So you got to find that y-intercept first, and from that y-intercept move your slope. And that's what it would look like. This is a positive line. It's going in the uphill direction. Now let's look at a line that's going in the negative direction. Let's say I give you a slope of negative 2/3 x plus 1. Well, if you remember from the last graph, what we do is we always start by graphing our y-intercept first, and the y-intercept is this number that's by itself. In this case, the y-intercept happens to be a positive 1, so I'm going to go to a positive 1 and put a point. We're going to do everything from that point. So from this point, positive 1, we're going to move our slope. Whatever that slope may be, we're going to be moving it from that point. That's why that's so important. This slope happens to be negative. It's negative 2/3. So you've got two options. You can go down to right 3, or you can go up and left. So let me show you what both of those would look like if you follow my point over here. I can go down 2 and to the right 3, giving me a point over there, down 2 to the right 3. Notice I'm just following a pattern here. You can go as many times as you want, or from that original point, I can go up to left 3, up to left 3. Once again, you can do it as many times as you want. It doesn't matter. And what that does is it creates a line for us. So let me show you that line. Of course, you're using a straight edge, right? Of course, you're making your lines nice and straight and clean. Let me fix that. There you go. That looks a little bit better. And it would look something like that. A negative slope going in the downhill direction.